Welcome back once again. We are starting off with section 3.2. We're done with chapter 2. It's time that we get to the good stuff. The good stuff is graphing functions. The first kind of function we're going to graph are called polynomials, which is some of my favorite functions to graph. They're pretty fun. I like them. First thing we need to talk about is what polynomial means. What does polynomial mean? It's one of my favorite questions to ask in class because what it actually means and what it should mean are completely different things. What it should mean is poly is many, nomial means numbers, polynomial should be an expression with many numbers, multiple numbers, more than one number. That is not at all what polynomial means in math. My version of polynomial, again, if you remember my definition of function, the official, widely accepted, correct definition of a polynomial is complex and messy and not particularly helpful. If you're interested, look it up. You can find it on Wikipedia or Google. Type in definition of polynomial. You'll get a bunch of really wordy nonsense that's not extremely clear what it means. So, the working definition of polynomial, the thing that I will use to describe polynomials that's actually helpful and useful and meaningful for our class, is no weird stuff. Polynomials are the first kind of functions we're going to graph because they are, in many ways, the most basic kind of function. If something is a polynomial, that means there's no weird shenanigans happening in that function. Weird shenanigans include weird stuff means division by variables, and by extension, negative exponents. If you get expressions where you have division by variables happening, like if you just watched the section 2.6 video and you came here, first of all, good for you for watching them in a row. That's smart. Second of all, in that 2.6 video we ended up with a function combination where we took f divided by g and we got this rational function where we had an x squared plus 3 minus 3 divided by an x plus 10 or something. It was literally 5 minutes ago for me and I've already forgotten. But when you have that division by variable thing happening, you get domain restrictions. So in that video we had an x plus 10 in the denominator of this expression, and that means that we have a domain restriction. We have to make sure that x can't equal 10, and if we were trying to graph that, really weird stuff would happen when x got really close to 10, and it could never actually be 10, so there's going to be this break in our graph and it's going to behave erratically near there. It's just kind of a huge mess. Because it turns into a huge mess, it is officially weird stuff and it is not allowed in the polynomial club. Negative exponents, things like x to the negative 1, this means 1 over x, if you remember, and that is division by variables, and that is not allowed. So no negative exponents ever allowed in the polynomial club. Other weird stuff includes square roots, and by extension, fractional exponents. So, square roots kind of have the same problem that division by variables have. If you make a function with y equals square root x, that's great, that's a function, but it has these domain restrictions as well. you can't take the square root of a negative number. And so instead of trying to deal with these domain restrictions and trying to figure out what happens when you graph these domain restrictions, the better plan is just to avoid the whole thing entirely. No square roots allowed. Those are not polynomials. They just don't count. And fractional exponents as well, because again, x to the 1/2, that means square root x. So fractional exponents give you roots. Those are not allowed. So these are sort of the two big things that are not allowed. You can't have negative exponents. You can't have fractional exponents. Other weird stuff, sort of generally, would be exponents or exponentials. Or I'll say, let me say variable exponents. If you have an expression where your exponent is a variable, that would look something like this: y equals 2 to the x. This is going to give us some problems because sometimes this x is going to be negative and sometimes it's going to be a fraction, and we don't want that. This is called an exponential expression. And it is a different kind of function that behaves very differently from polynomials, and we'll talk about those later in chapter 4. Other things, logarithms. Logarithms are super weird. They behave kind of like exponential functions, except they have weird domain restrictions. They're sort of checking all the boxes for weird stuff, and they're definitely super not allowed in the polynomial club. So no logarithms, no trig. We'll talk about trig in chapter 5. It's fascinating. Other things, I'll say etc. So, you get the idea. Instead of trying to explain all of this every time we want to talk about what a polynomial is, the easy way to describe a polynomial is just to say there's no weird stuff allowed. So let's talk about, this has been an exciting conversation about things that aren't polynomials. Let's talk about some stuff that is a polynomial. So let's do something like y. Let me switch my because this one's not doing hot. Okay. Let's look at y. Oh, this is nice. Y equals, we'll say x squared minus 2x minus 8. This seems like a good polynomial. So, if we're trying to figure out whether or not this is a polynomial, we can look at the exponents. Right now this thing has exponents of 2. This thing technically has an exponent of 1. If you want to be very precise, this thing has an exponent of 0. We just usually don't write that. So all of these exponents they're not fractions, they're not negative, so that's good. And there's no trig, there's no logarithms, there's no exponential expressions. This is just polynomial, no weird stuff. Good, clean fun. So here's what's allowed in the polynomial club. Positive whole exponents. No fractions, no negatives. Any coefficients you want. So here our coefficients can be -2, they can be 1. If you want to get weird, you could say that this coefficient is pi, or like weird numbers, whatever you like. Coefficients can be anything. Coefficients never count as weird stuff. Coefficients are always very safe and reliable and easy to use. So coefficients can be anything, they never count as weird. You can put a pi here. That's safe. So, anything you want, this is a polynomial. As long as you've got positive whole exponents. So if that's what a polynomial is, the next question becomes, how do we graph a polynomial? And for that, I'm going to flip to the next video.